In this video, I want to have a look at permutations. So first off, we need a definition of what permutations are. So a permutation describes the number of different ordered ways that we can make a selection of R objects from N objects. So it's really important that we are talking about ordered selection, so order matters. So we might be picking, say, a first, second, third place, or we might just be arranging things in a row instead of just in a group. So permutations are when order does matter, but we're not just arranging N objects in a row. We've got N objects, say 20, and we only want to arrange a certain number of them. So we might have 20 objects, but we only want to arrange, say, 5 of them. So for example, let's have a think about if we had, say, 20 photos, and we want to arrange 5 of them in a row in frames. So we've got 20 of them. Now, if we were going to arrange all 20 of them in a row, we would have the calculation 20 times 19 times 18 times 17, all the way down to times 3 times 2 times 1. So that's the number of ways we could arrange all 20 of them. But we don't want to do all 20 of them. We only want to arrange, say, 5 of them. So we would only have the first 5 of those numbers. So we'd have 20 times 19 times 18 times 17 times 16. Now we have a shortcut for writing this. We already know the shortcut for writing this from 20 all the way down to 1 would be written as 20 factorial. But if we're cutting it off, we're cutting off everything under 16. So that means we don't want the 15 times 14 times 13 times 12 all the way down to 1. So the way we're going to write that is as 20 factorial over 15 factorial. So we've gone 20 factorial over 15 factorial to get rid of everything below that 16. So we've only got the first 5 numbers. The other way to think about that is we could have 20 factorial over 20 minus 5 factorial. And that's where our 15 came from. So the 20 minus 5 is we started off with 20. We want the first 5 of them because we're arranging 5 objects, but we don't want anything else. So we can do that. So that's going to lead us into the definition of a permutation. So permutations. You have a button on your calculator that has a P with an N and an R. So this is the permutations button, and that's saying we've got N objects and we're picking R of them. And the definition for a permutation is N factorial over N minus R factorial. So on a Casio calculator, that button is just above your multiplication sign. On a Sharp calculator, it's just above the 6 button. So you're going to have to go shift or second function to get this. So for example, if we had 9 objects and we're picking 4 of them to arrange them in a row, you're going to put that in your calculator and you'll end up getting 3,024. So that's equivalent to doing 9 times 8 times 7 times 6. But it's the shortcut of doing it. So your calculator is going to calculate that for you using this little formula. All right, there's a couple of other problems that we need to have a look at and a couple of different situations that we need to know how to solve problems in those situations. So the first one we're going to have a look at is if we've got restrictions on something that's happening. So one of the things we keep coming back to talking about probability and arranging things is people going to the movies, and it's because they sit in a row. So say that we've got 9 friends that go to the movies and we want to arrange them in a row, but in those 9 friends there's a couple and that couple wants to sit together. So we now have, if we call our people A, B, C, D, E, F, G, how many is that? 1, 2, 3, 4, 5, 6, 7, G, H, I. So there are 9 friends. Now normally we would have 9 factorial ways of arranging them. But the problem is that 2 of them want to sit together. So say A and B are the couple. So those guys want to sit together, which means really if we count them as 1 object, then we only have 9 objects. So instead of doing this, we're going to have 8 factorial. But within those 2, there's 2 factorial different ways that we could arrange that couple. We could have AB or we could have BA. So now we've got 8 factorial times 2 factorial. And that is going to give us, it's going to give us 80,640 possible different arrangements for those friends. One of the other things we need to have a think about is when things, instead of being arranged in a line, like friends going to the movies, are when things are arranged in a circle. So, for example, if we had a dinner table. So we have 7 friends, and they're going to sit around a circular table at dinner, and we want to know how many different combinations there are. So our first person, they can sit wherever they want on their table. But then the arrangement that comes after that, there's 6 people left that we have to arrange in a line around that table. So because of that, there will be 6 factorial different ways those 7 people can sit around a circular table. And 6 factorial will give us 720 possible different combinations. Now, the reason it's only 6 factorial is if we're sitting in a circle, then lots of the arrangements that we would have had if we were arranging 7 friends in a straight line are actually the same. So for example, if we think about 4 people for a second instead, because it's easier, if we had 4 people called A, B, C, and D, then that arrangement, if they're sitting in a circle, is the same as B, C, D, A. So they're still in that same order because the end is joining up to the start. So that same thinking still works for this. So if these guys were in a straight line, there'd be 7 more possibilities for how we can arrange them, or 7 times as many possibilities, sorry. All right, if we still think about this question, so we've still got our 7 friends sitting around a table, I'm going to change this question a little bit. Instead of just arranging the 7 friends, I'm going to say that 3 of them want to sit together. All right, so A, B, C, D, E, F, G. So I've got 7 friends. These 3 guys, A, B, and C, they all want to sit together at that table. So I now have one group of people, so we're going to group those A, Bs, and Cs together. So that's one person that I'm thinking of them now. So one group, 2, 3, 4, 5. So instead of arranging 7 objects now, I'm only arranging 5 of them. Now because, again, this group can sit wherever they want on that table, so there's going to be 4 factorial ways that we can arrange the 4 of them. But those 3 people can shuffle the way that they're sitting as well, as long as they're still together. So there's 3 factorial ways that we can rearrange those 3 people. So we're going to have 4 factorial times 3 factorial, which would give us 144 different possibilities for the way that 7 people can sit around a table if 3 of them have to be together. All right, the one last thing that we need to have a look at is if things are repeated. So say that I had the word permutation. Get rid of that S for a second. I've got the word permutation. I want to figure out how many different ways I can arrange those letters of the word. So in that word there are 11 letters. So we would have 11 factorial different ways, except we have 2 T's in there. So 2 of the letters are exactly the same, and it doesn't matter which way you put those T's, the arrangement of those letters is still going to be the same. So we're going to have 11 factorial divided by 2 factorial because there are 2 T's. So then you would work out that. Say we had the word probability. Let's write it down here. Right, so we've got the word probability and we want to rearrange those letters. So again, it's an 11-letter word. But in this case, we've got 2 B's and we also have 2 I's. So this time we're not only going to have to divide by 2 factorial, we're going to have to divide by 2 factorial times 2 factorial. And that would give us the number of different possibilities of the ways we can arrange the letters of the word probability. And the reason we have to do that is because the letters can be repeated. All right, so that's an introduction to permutations.